everyone, myself Blessy here. I am working as a scientist in the discipline of Land and Water Management Engineering in the Indian Institute of Soil and Water Conservation, Regional Center, Udhagamandalam, Tamil Nadu. In today's lecture, we will see about engineering measures for reverting land degradation in the Nilgiris. In today's section, we will understand the importance of soil and water, explore the threats to sustainable soil management, and discuss various biological and engineering measures that can help conserve these vital resources. We will particularly focus on practical soil and water conservation structures suitable for the hilly terrains of Nilgiris. Now we will see the importance of soil and water. Soil is a biologically active porous medium that has developed in the uppermost layer of earth crust, and it's serving as a reservoir of water and nutrients, medium for filtration and breakdown of wastes. So the soil is developing through weathering process, and around 500 to 1000 years will take to form 1 inch of topsoil. And 1 cubic meter of soil can retain over 250 kilograms of water, while damaged compacted soil loses almost half of its retention capacity. If we look into the importance of water in earth, if you see, fresh water is only 2.5%. Out of that, if we see the available water, it may be less than 1%. Respects its importance, soil is under severe threat. Major issues include soil erosion, soil organic carbon loss, nutrient imbalances, acidification, soil contamination, waterlogging, soil compaction, soil sealing, salinization, loss of biodiversity. Out of this, soil erosion is one of the major problem for sustainable soil management in India. Further, we may see more about soil erosion. Soil erosion is the process by which soil is detached from the earth's surface by exogenic process such as wind and water flow, and then transported and deposited in another locations. So if you see into Indian condition, in India the total gross erosion is estimated about 1559 ton per square kilometer per year. Out of this, around 34% soil is deposited in reservoirs and 23% is discharged to oceans, and the rest is displaced within river basins. The northern river basins of India contribute nearly 81% of sediment yield compared to 19% from southern basins. So the loss of fertile topsoil reduce agriculture productivity, cause chemical runoff into water bodies, and lead to flooding due to reduced infiltration. For this slide, we will see how we can address the soil erosion problems. So for that, we can opt different types of conservation measures. There are mainly 2 types, biological measures and engineering measures. And biological measures are such as vegetative barriers, alley cropping, cover crops, and agroforestry practices that reduce runoff, improve infiltration, and enhance soil fertility. So here in these figures you can see different types of biological measures. The main objective of these biological measures is to prevent splash erosion. So that is one type of soil erosion problem, and accumulation of soil particles reduce the velocity, surface runoff, and increase infiltration. So next type is engineering measures. Engineering measures are which involve mechanical structures designed to complement biological practice. These include terrace, bunds, trenches, check dams, retaining walls, and other water conservation structures. So here the main purpose is to divide the long slope into small parts so as to reduce the velocity of water and reduce the velocity of run of water and retain it for long period of time so as to allow maximum water to be absorbed and held in the soil. So next slides we will see more about different engineering methods. Now we will see more about different type of engineering practices. So let us begin with terrace practices. Terrace farming is one of the oldest and most effective soil conservation technique for hilly region, and it is particularly suitable for slope ranges from 10 to 33%. And it involves constructing multiple flat surfaces on mountains or other uneven surfaces, and these layers give illusion of staircase steps on mountains. So this figure you can see. And bench terracing is also known as benching or step farming, involved constructing a series of flat platforms or bench across the slope. So here the main purpose is diversion and retention. So there are mainly three different types of terraces: level, inward and outward, based on soil type and water holding capacity. On steepy land slope, the slope where terraces are found useful vary from 10 to 33%, and bench terrace with 100 meter length, longitudinal gradient in the range of 0.2 to 0.8% are recommended for alphys, also high rainfall regions. In hilly areas, cultivation of horticulture crops under bench terracing method conserve soil moisture and reduce nutrient loss and increase the yield and also reduce soil erosion problem. So this slide is a pictorial representation of different types of terraces. So the first one is outward type of terraces, and here the main purpose is to store the water. And this figure you can see here, first one is level terrace. So this is mainly suitable for paddy cultivation and all. And last one is inward type of terraces. So here you can see a toe drain is given for safely removing excess water. Another interesting type of terraces are puratorical terraces. So here, unlike conventional mechanical terraces, these are developed biologically by using vegetative barriers. So for example, in this figure you can see, so here we will do planting of vegetation at a 5 to 6 meter interval. So the process involves planting grasses or shrubs along the contour at predetermined interval, and species such as Udhagamandalam grass are suitable for Nilgiris region. As cultivation continues, so first year soil will erode from this top portion and deposit downstream side, and gradually with 3 to 4 year natural terraces will form. So this last figure you can see after 4-5 years how the terrace is formed. So if we look into this process, this technique is a low cost, does not disturb the topsoil, and is particularly suited to resource poor farmers in hilly terrains. However, it requires patience and careful management in the early years to establish vegetative barriers. Although terrace practices are highly effective in controlling soil erosion and conserving moisture, poor maintenance and improper design can lead to their failure. So this slide we will see some examples of terrace mismanagement. The first problem is terrace abandonment. So when farmers stop maintaining or cultivating terraces, natural processes like erosion and vegetation encroachment can degrade the structure over the time. So this figure you can see, this is a terrace abandonment. Second, we often see terrace collapse. This usually happens due to inadequate compaction, poor drainage or heavy rainfall event that the terrace was not designed to withstand. Another issue is piping in the abandoned cultivated terraces. So here you can see small piping occurred in the terrace field. So this gradually may lead to landslide problems and all. Next is we also see landslide on abandoned terraces where soil slip progress into small debris flow along the slope, and this not only damage the terrace but also poses risk to downstream community. And another problem is instead of wrong practices, like instead of inward slope going for outward sloping terraces. Half-moon terrace is another important practice. It is constructed by cutting the land surface in the shape of half-moon to create circular level bed having basin of 1 to 1.5 meter diameter. And these are using for planting saplings of fruits and trees in the slope. This method is particularly effective in semi-arid and hilly region where moisture conservation is critical for tree survival. Moving on to bunds, it is an embankment-like structure constructed across the land slope using for obstruct the path of runoff and reduce the velocity of water and store the water. So usually this is constructed in a slope range of 2 to 8%. So there are also two different types of bunding practices. First one is contour bund, and this is usually suitable for low rainfall areas where rainfall is less than 600 mm and high permeable soil types are there. So the main purpose of this type of bund is to store the water. Next type is graded bunds. These kind of bunds are useful where high rainfall, where rainfall is greater than 600 mm and low permeable soil. So here the purpose is safely dispose the excess water. Grassed waterways are another important conservation measures. They are gently sloping channels established with the grasses or legumes to safely convey excess water from cropland to an outlet such as a river or reservoir. By lining the channel with the vegetation, we reduce the velocity of flowing water, prevent rill and gully erosion, and promote infiltration. So based on shape of the channel, there are different types of grassed waterways like trapezoidal, triangular and parabolic, and different types of vegetation we can use in this case of grassed waterways like different grasses, legumes and small grains. So now we will see more about trenching practices. So trenching practices is a widely adopted technique for slope stabilization and water conservation. A typical trench is about 1.5 to 2 meter length, 0.5 meter deep and 1 meter width. And trenches are usually constructed on a land slope with slope ranging from 10 to 16%. And they act as a barriers, slowing down surface flow and allowing water to percolate into the soil. So there are different types of trenching methods. Contour trenching, where trenches follow the natural contour of the slope, and continuous trenching, which create an unbroken line of trenches. Then staggered trenching, where trenches are spaced in an alternative pattern to break the slope. So these figures you can see staggered trenching practices. Then inline trenching, aligned with the progress or plantation lines. Trenches not only check erosion but also promote vegetative growth in degraded lands. Now this slide we will see more about check dams. It is an important DLT measure. So check dam is a barrier or a small dam constructed across the water flow to lower the flow velocity. And check dam retain the water behind them. Likewise, it helps the surrounding soil to wet for a long period of time. And this check dam can be built by using various types of material like earth, sand, timber, stone and concrete. So there are mainly two types of check dam based on lifespan: temporary check dams and permanent check dams. So the first figure is showing a temporary check dam and second one is a permanent check dam. Next, let us discuss about temporary check dams. As the name indicates, these are the short-term physical and structural measures constructed across small gullies or streams. Their primary purpose is to slow down the flow of water, trap soil and sediment, and create conditions for vegetation establishment. So, temporary check dams usually have a lifespan of about 3 to 8 years, and they are not permanent solutions but act as important interventions until more stable vegetation or long-term structures are developed. So there are several types of temporary check dams. For example, brushwood check dams, which are constructed using branches and brush material. Log check dam, made from wooden logs placed across the gully. And low stone check dam, built with unmortared stone stacked to reduce flow velocity. Boulder check dam, using larger stones or boulders for greater stability. Gabion check dams, constructed with wire boxes filled with stones, which combine strength with permeability. Now, let us move on to permanent check dams. These check dams constructed permanently for a large lifespan, and these dams generally constructed by using concrete, steel, rock or composite of 2 or 3 materials. Spillways are structures that constructed to provide safe release of flood water from a dam to a downstream area. There are major 3 types of spillway commonly used in permanent check dams: drop spillway, drop inlet spillway and chute spillway. Drop spillway. In a drop spillway, the overflowing water falls freely and almost vertically in the downstream side of the hydraulic structure, and this type of spillway is suitable for weirs or low check dams. And in drop inlet spillway, water enters through the circular or box type closed channels. And in case of chute spillway, in this type of spillway, the water after flowing over a short crest or other kind of control structure is carried by an open channel to the downstream side of the river. Retaining walls are structural measures designed to hold back soil and water and prevent landslides on steep slopes. A retaining wall typically consists of a base, top and stem. This base is kept wider than the top to withstand increasing soil pressure with depth. Materials such as stone masonry, reinforced concrete or dry rubble may be used depending on site conditions. In the Nilgiris, retaining walls are especially important for stabilizing roadside cuttings, protecting farmland from landslides and supporting terraces. Finally, water conservation techniques form an integral part of soil and water management. Since rainfall in India is highly seasonal, we must maximize water storage and minimize runoff. Conservation strategies include for this surface water storage by constructing reservoirs and tanks, rainwater harvesting by capturing rainfall where it falls for immediate use, and groundwater recharge by promoting infiltration through recharge wells, percolation tanks and other structures. These techniques enhance water availability during dry periods, improve agriculture resilience and reduce dependency on external sources. Summary: engineering measures such as terraces, bunds, trenches, check dams, retaining walls and water harvesting system plays a vital role in soil and water conservation. When integrated with biological measures, they not only reduce erosion and land degradation, but also improve agriculture productivity and sustainability. For fragile ecosystem like Nilgiris, adopting such measures is critical to ensuring long-term ecological balance and food security. Thank you all for joining this section.